I'm here on a Friday at the EGU 26 with Alicia Neesemann, a remote sensing analyst and planetary scientist at the Free University in Berlin, who gave a fascinating talk yesterday on the dwarf planet Ceres, which wasn't always a dwarf known as a dwarf planet,
Right.
but it was the first asteroid that was, I believe, named or discovered way back when, I think in the late 19th century. Or am I wrong about that?
No, you're right. It was, I think, even earlier. I don't remember the exact date, but yeah, it was one of the first asteroids because also it's the biggest, one of the biggest, however darkest, that was discovered. Yes.
So tell us the essence of your abstract and your presentation yesterday.
Right. So I presented a recent paper in which we again went back to Ceres, investigating the very high resolution data that was acquired like at the end of the mission. And yeah, so we created like a very elaborated framework to first process these high resolution data, created high resolution digital terrain models that we could auto rectify these on. And then we went back and did crater counts in order to determine the age of these very bright deposits that turns out are just a couple of million years old.
That's basically today by geological
Right.
standards.
Right.
And so your conclusion was that the surface of Venus, the surface of Ceres, I have Venus on the brain, is much more complicated than you originally thought. Is that right?
Right, that's
How
right.
so?
So first we thought, okay, Ceres is one of these just cratered asteroid bodies. And what we didn't expect were these cryovolcanoes, like Cerealia faculae, Vinalia faculae, and Ahuna Mons. So we haven't seen cryovolcanoes at that kind of freshness on other bodies, for example, even if they exist on icy moons, for example.
And what is a cryovolcano?
A cryovolcano is basically just a volcano that happened at lower temperatures, basically below the freezing point. And usually it's volcanism based on water and salty water mixtures, and not based on silicates or iron.
But you don't really know what would you say is driving the cryovolcanoes if you were pressed to say on Ceres?
It's a good question. I mean, on Ceres, we don't have heat in the interior from tidal heating, for example, like we have on Enceladus. But on Ceres, specifically when it comes to Cerealia faculae, or Cerealia tholus, how it is also called, it is a mixture of impact-induced heat and like the reworking of the subsurface. So it basically has hit like a subsurface brine reservoir, which allowed these kind of water icy mixtures to reach the surface through tectonic faults that formed as a response to the impact.
And what's different about Ceres from the other main belt asteroids, with the exception we know of Vesta, is that Ceres is a differentiated body. Explain what you mean by that.
Well, Ceres is separated into like a core and a mantle and the crust. So that's what we call being differentiated. And the difference is that Ceres has this unique high water content. Like it has about 22 to 27% of water, which is like, I think beyond the Earth, the biggest accumulation of water in the solar system.
And we don't know about Pallas, which
Right.
is not in the plane of the ecliptic.
Right.
And it's more difficult to get to. To my knowledge, I don't think anyone has ever flown by Pallas.
No, not yet.
Okay. But you were telling me in the interview just now that you think that because of Ceres' high water content, that it could have formed much further out in the solar system.
True. I mean, this is something that is still under investigation. I'm not the expert on that, I have to admit. This is what dynamical modelers do, basically. And but yeah, the possibility still remains.
But you are involved on the science definition team of a potential NASA JPL mission
Right.
for a sample return from Ceres for the
Right.
first time in history.
Yeah.
And so tell us a little bit about that, how that is going, what kind of mission it would be, and potential ballpark date for maybe a launch if it goes through.
Right. I mean, I can't give you a potential launch date. But when it comes to the mission, it's supposed to be a lander and a sample return mission. And currently we're still in the concept phase, like defining the assigned packages. And what I'm specifically doing is I'm part of this topography group. You know, these missions always have topography groups because we need to know like what is like the roughness of the surface. Is it safe to land there? We have to conduct a lot of risk assessments. And this will basically be my part and contribution then to the mission.
So what puzzles you personally? I know you only deal with only a part of Venus. There we go again, of Ceres science.
Right.
What puzzles you personally about Ceres most?
Good question.
There are no wrong answers.
It is true. I mean, I'm just curious about what we see on planetary bodies that we haven't reached and seen before. This is my like intrinsic scientific curiosity and driver. But on Ceres, it was the freshness of some features and the fact that we found like cryovolcanoes. That was very interesting.
And the other thing is, you were telling me that it's a carbonate world. It's a very different kind of asteroid than most asteroids, and you can't even compare it to the Earth, Moon, or Mars.
Right. That was basically also one of the reasons why we wanted to go there, because it was so unique. We have previously visited Vesta, and since Ceres is so different, we wanted to understand that more.
Well, so when will the definition phase of this potential sample return mission be finished? Do you have any idea?
A good question. That rather depends on NASA's reviewing board, I guess.
But you would hope within the next year?
That would be a nice outcome, yes.
Okay. So thanks so much, Alicia, for your time today. Really fascinating. We look forward to hearing more from you on Ceres.
Thank you.